the actual word apple and not the apple itself. But what it does is it takes that word, runs it through their embedding model, and comes out with a token. And it's these tokens, these internal representations of an idea, is what is being emulated in the, from what humans do. So this concept of having a semantic architecture for safe, secure, and reliable autonomy is built around these three concepts. Agents, which are, represent the agents that we talk about with AI, but they can be people, right? You can have a person representing that AI. They should be, the goal is to have the AI emulate the behavior of a person as close as possible, if not better. And then you take these agents and you build them into organizations, and that's groups of agents that are collaborating on a specific task. And the way we describe the tasks are missions. What are the organizations doing, and how are the agents commanded to perform their functions? In the Air Force, we call it command and control. And I bring this point in here, it's regardless of whether the agents represent people or AI, you can take the same architectural approach. And I think that's a really important part of it, because it guides some of the decisions about how you organize agents and how you put in controls and what type of performance criteria you're looking for. And this is more of a legal requirement, but meaningful human control is always a requirement for the AI. And it may not be direct human control. It might not be a person authorizing every decision that the AI makes, but there should be, at an organizational level, a human control that's determining what the agents are authorized to do and how they perform those functions. I'm going to repeat the point again. It shouldn't matter when you're looking at this from an architectural perspective, whether we're talking about an agent that's a person that has a set of training and an identity and authorizations to do things, versus an agent, an AI-based agent that can emulate those behaviors. And I keep repeating myself, but I think that's an important part about how the system is architected. Organizations, are the things that define the roles and responsibilities for its agents, and the organization can assign specific authorizations. And I'm not just talking about, a military organization or something, involving robots. The same approach applies to financial organizations that want to use autonomous systems to improve their performance. There's going to be a meaningful human control at the top. The agents will probably be aligned close to the way the human organization is aligned, and they'll get authorizations to make certain decisions based on where they sit in the organization and what kind of authorizations their meaningful human control provides to them. We've had discussions about whether a disorganized amorphous swarm is better for autonomous systems versus a hierarchical system, and I try to be neutral on that point, because there's probably cases where each one has its advantages, but I think in general we should be organizing the agents along the same lines of authority that we do for people. And I think it improves the safety, security, and reliability, because there's a better understanding of what they're doing, and you have a better chance of explaining their behaviors that you may not have if you treat the agents as an amorphous swarm that self-organize to form their own organizations. The concept of a mission has a specific meaning in the Air Force, but I think it translates really well into other types of organizations. There's I put a reference in here to the DoD Mission Engineering Guide, and it's a publicly available document. It's just out on the web. I don't think you need any authorizations to look at it. But what they what it highlights is the idea that basically every organization has to do this to be successful. You have to decide like what are your goals for whether at long-term strategic goals or short-term tactical. You should have the same approach. You look at what define that goal as clearly as possible, define the timeline that it needs to execute on, the resources that are available, the risks that you need to avoid, and how you're going to measure performance, and then design the the actual implementation that's going to accomplish that mission around those requirements. And for human stuff, like if you think of a cargo mission, um, you can picture a mission where you want to deliver a couple tons of humanitarian relief somewhere in the Pacific. The the organization that would take care of that would probably look at that problem and say, well, if we have to do it really quickly, we'll put it on a C-130, we'll fly it out of Hickam, we'll drop it off at that island or the nearest, airfield and get that material to them as soon as possible. But if the question is more about a mission to, a large scale disaster like on Guam or in the Philippines, it's a whole different mission architecture because now you're looking at, instead of bringing in a couple tons of material, you're bringing in hundreds or thousands of tons of material, which would involve, not just single C-130 flights or even a train of C-130s. You have to bump it up to the next larger aircraft. You'd probably bring in, maritime support to bring in cargo ships and supply it. But that's the type of things that happen in mission engineering. What are the goals? What's the timeline? What are the constraints that are on it? And then design it through. And the reason why I'm spending a lot of time on this is I think the approach that we should use for autonomous systems and organizations of autonomous systems is the same basic approach and have the same products that come out of it. Like the artifacts that come out of this approach provide the inputs that go into the planning and execution of a mission, and following that basic idea of treat the organization of agents the same way you would an organization of people. People get their orders, in documents, that are clearly, describe what the mission is and what their role is in the mission. And then there's plans that produce the timelines. I think that same general approach would apply to autonomous systems. I don't want to get too much into the nuts and bolts here, but there's a bunch of frameworks that are available. It seems like the current leader is this Anthropic's Model Context Protocol and Google's Agent to Agent, but it could probably change, or it almost definitely will change over the next couple of years. But the idea here is that you have a framework for taking a large language model, which you can think of as a kind of a general purpose foundation model, and use MCP to modify its context. And that context includes things like the documents that it has access to, the and which documents are actually loaded into the agent's context, into its working memory, what applications it has access to, and what kind of things it can do, like on the internet, what kind of decisions it can make, and can it place orders, can it do financial transactions. And the way this is evolving is when you look at Model Context Protocol and the way the different types of tools are being defined, and how you interface, how the large language model interfaces with the greater world. Having this approach of, if that agent is sitting in a specific specific role within an organization, that it should have access to the same information that a person sitting in that position would, through Model Context Protocol. What applications would that person have? The agent should be able to access them with the same authorities through MCP. And that way there you can evaluate the performance of that agent relative to a person sitting in that same seat. Um, you're not going to, there's discussions about whether you should pre-train the models to include all the information that a human would have been trained on sitting in that spot. But it doesn't appear that that's really a requirement, that making those documents available and having a way of interfacing the agent with those documents and so they can efficiently find the information that's needed seems like a more viable approach. There was a recent, excuse me, there was a recent survey published, a group at Shanghai University back in April, looking at the different protocols, and I found it to be really interesting. It's one of those papers that I found by watching the YouTube video about it first. But this is kind of how they view the agent, ecosystem, and they go through the different leading frameworks, and I think there's like 13 or 14 of them, and how they relate to each other. What strengths and weaknesses. One of the important things that I think will be necessary to define up front in this architecture is what is open standards for data security, identity management, and transaction processing. And if you've heard me talk about this before, you know that I'm a big fan of blockchain-based approaches. And it's not necessarily public blockchains or private blockchains. I think they each have their own role. And it's not that every transaction needs to go on the blockchain, every communication, every message, but there's the designers should have the ability to determine at what point do you log data on the blockchain and what types of transactions need to be recorded there, what type of data actually gets passed through blockchain-based data transfers. I put this line in here. If you think of the way people use blockchain, it's not something that they use to do, say, social media type chat, right? It's like that happens in a different area because the security requirements aren't as high. But you use the blockchain to provide identities that are necessary for things like, economic transactions, paying bills, receiving funds. Those same criteria and controls, I think, apply to command and control of autonomous systems in an organization. And the blockchain gives you the ability to define what those are and maintain a log of actually what those authorities were over time, so that you can always go back and recreate what those authorities looked like. And then there's other options that can do this. I'm just, I'm interested in hearing alternatives. If there's something better, something that's more secure, more robust, more reliable, definitely interested in hearing about it. And the summary is, I wanted to present an approach that can be used to create organizations of agents that collaborate to execute missions. And I'm looking forward to the any questions or comments. Wow, I did that pretty fast, I guess. But I don't know. If you've heard me talk about this before, a lot of it's probably old news. But hit me up. Where do you see the risks? What could be done better?
So just going right back to the blockchain, the risk always with going to blockchain is the latency in the chain. So I think blockchain is a great way to record, logging it and like forensic traceability of information. But getting stuff into the chain and confirmed into the chain is by no means fast, even in the fastest chains. So I think there's a risk there. I think you need to look at how you send data out securely and then maybe a parallel process for the accountability part, from agent to agent, particularly in real time systems where you don't have time to wait for confirmation to be put into the chain prior to executing it on it. And I'm not talking. I'm talking even the fastest chains. Like, so, I mean, the original blockchain, I think, Bitcoin blockchain had a 10 or 15-minute confirmation, and you have to go through 2 rounds to make that secure. And the modern blockchains are much, much faster, but they're by no means real time, right? They're
And that's all based on the consensus protocol, right?
Yeah.
If I have a closed network, I could have a a system where I've got one node that's doing consensus, and everybody's on a local network, and then you'd say, like, all those concerns, like, oh, then it doesn't really, the latency doesn't matter. And I'd point out that I think it's like $10 billion a day gets transacted over the Ethereum network.
Yeah.
It's like, that's a lot of money. So like the delays could be maybe minutes, but there's some things that don't require instantaneous transaction. Like registering as an available agent. I could do that with
I think blockchain is a wonderful idea for identity management, right? Because that is a startup issue and not actually a decision issue, and it's easily verifiable in the chain. So for identity management, it's great. The concerns I have is and I still think it's great, even for forensic logging of this is the
high
chain
bandwidth traffic. Does not make sense.
Yeah.
But I think it's definitely good for the identity management, command and control type things. Not like tactical command and control, but kind of broader command and control, like to providing missions to parts of the organization, things like that. That if you're going to use the public blockchain, it has to be designed with minutes maybe of delay, but on local networks it's kind of a design choice. It's like, what does your network support? You can make the blockchain as fast as you want, a private blockchain.
In particular if you go with proof of stake over proof of work, but
or just trusted. If you say, hey, I'm going to have a token on the nodes that are in my network and I control them, and then they don't even really need consensus. The voting could be really quick. Well, I don't know. I shouldn't say they don't need consensus. The consensus, deriving consensus, could be really quick if you only have a few nodes. But,
Kevin, can I make just a comment, because this is very interesting. Yeah, I know you're smiling. Don't worry, I'm not going to mess things up here. But let's go up to a higher level. There's basically 2 kinds of systems. Okay, one is the hierarchical one, which you spend a lot of time talking about, which is great. Okay, it's very predictable. And at the other end of the spectrum is a totally distributed, decentralized swarms. Okay, now the advantage of decentralized and distributed systems is it's very secure, because you don't know what the hell it's going to do. Okay, and as opposed to the hierarchical system, which they are inherently centralized and less secure than distributed, decentralized swarms. So it'd be interesting is if there's a hybrid model, to build in. I like the notion of a hierarchical system. If some degree of unpredictability could be built into it, because then it's harder for the adversary to figure out what you're going to do. So that's just a comment. And
and this isn't all about like military systems, though. Like, this is also about systems for doing logistics. I think the same rules apply. You want some level of autonomy, but it's got to be controlled. I see Joe's on there. It's like, what is the Army's, how does the infantry operate? It's very hierarchical. But then when you get down to a platoon level, they've got a lot of freedom of movement. Or I think even at multiple levels, the commander has freedom of movement within certain restrictions, and they've I don't know, Joe, what's the term? Centralized command, distributed.
Yeah, there's disciplined initiative would be the principle, I think. And yeah, so I think that's the principle. But I guess I'm not sure from an agent perspective that this amorphous versus hierarchical trade-off will apply when it's deployed to edge. Like, if everything's in the cloud and the cloud disruption is broken, then whether it's kind of peer to peer, whether there were peers or there was a hierarchy, the connection's broken. So it doesn't matter. If it was deployed to edge, we're probably gonna the hierarchy is probably more of whether multiple agents or multiple different stores of instruction, and they'll all have to be stored within the unit of operation, whether that's one UAS or a convoy of UAS. So I don't know. I guess my point is the amorphous system, let's say they were split up, you had 3 drones make a convoy. There's a lead drone that stores the planning agent and 2 kind of wingman drones that don't have the planner agent. But you have 5 of those convoys making up the overall system. The behavior of those 5 could be somewhat amorphous. But if they're all pursuing the same mission, I don't think it would conflict with hierarchical. But then within the convoy, it'd be more hierarchical. You take out the lead one, and then it would. So yeah, that was just yeah. I don't know. That's kind of where it's going.
But what would be different if those were convoys of people driving vehicles?
Yeah, I think the main difference, and I don't think it would be. So the difference would be, all right, if you shoot at the commander or NCO, does their next in line have adequate competence and training to complete the mission? And I think you could, again, agents are stores of instructions more than anything else. So I don't think you probably would just store all the relevant instructions on each device. There shouldn't be a huge trade-off in doing that. So anyway, yeah, it's the difference is that the agents, if they lack the instructions or they lack, or maybe they're fine-tuned out language models. So it's I don't think that would be an issue, but I guess the hypothetical issue where it would come up where hierarchical would be an issue and it would contrast with people is okay, with people, there's a brain that is built with reasoning and judgment capabilities, and that's present for sure. Or I see you laugh. We're hoping it's present. But we're not designing people, so there's some faith and there's an assumption of that. With the agent, it's if you had one small language model fine-tuned for planning and control and another one only for execution, maybe that'd be an issue. But I don't think that would happen, just because the one that is planning is also going to have execution because it's flying around with the 2 that execute. So why not put the planning on those 2 as well? So and yeah, I could think of a few reasons, but yeah. So I don't think the trade-off is too severe is my overarching point. I think you can behave like a centrally organized formation and a distributed organized formation with an edge deployment of the agents, with agents. Yeah.
As long as that authorization is clear. And I think that's my only point is that you could say, hey, I'm at this organization, and the agent at the top says, I want all these agents to act independently as a swarm and only care about your nearest neighbors and don't worry about the big picture. That's a form of control, right? There's probably some cases where it's valid.
Yeah,
if you're looking for a lost hiker, right, you may want to just say, hey, I'm going to just distribute these drones throughout the area because it's a randomized problem, right? You don't know where that thing that they're looking for is over the space, and
yeah, it'd probably be rules of engagement, and the authorization would be which agent or person is authorized to issue rules of engagement. In the last 20 years, rules of engagement have been issued from very high authorities, but maybe in a broader like scenario, you would even have agents with certain authorizations to issue ROE, and that could happen at HQ prior to the mission, and then like, yeah, so the authorization to issue ROE could determine whether they operate like independently, nearest neighbor, or in some sort of synchronization.
All that makes a great deal of sense. It's like if you had a slider bar. At one end, it's pure hierarchical, pure. The other end, it's pure distributed. And then you slide the bar in between, okay? And so I would suggest building that slider bar into the architecture. Where do you want it to be pure? You don't want it to be purely hierarchical, but where in between do you want it?
It would be in a document that was called organizational structure, and it would say like, this is the agent that makes like that, I don't know, that does some assignment. Like, somebody's got to be the entry point for commands from the outside for and then that document should be human readable, so that I can look at the document that's being provided to the agents and understand how they're being set up. And it could be something like, hey, you're gonna deploy in groups of this many to these points, and then when you get there, the control will be handed off to the local drone, and they can decide to randomize things or just act as a swarm, whatever is most appropriate. Right?
Yeah, that's the slider bar. You just defined the slider bar.
And the slider bar is a document, though, and if you think of it that way, so that you read it, and the intent of that organizational structure is clear.
Yeah, no, I think that's a good idea. Oh, okay, all right. I made my comments. I'm done.
I got 2 comments about the slider bar, because I think that's an awesome way to conceptualize it. And the challenges with the slider bar is that there are certain tasks that require the slider bar to be in particular positions. For example, if you want to build an automobile, that slider bar has got to be way to the hierarchical thing to get everybody doing the right thing to build that contraption. And the other thing is, sometimes your slider bar gets taken away from you. Like, you're in an operational setting, you had a plan for more centralized control. Say, for example, we're boarding an aircraft, right? We've all been in the airport, Group A, Group B, whatever. Most people know what's going on. Some people don't. But then all of a sudden, if the announcer stops talking, well, you got to get on the plane anyway. So you got to figure out what to do with the information you have without that slider bar. Now that you're way on the decentralized thing, so you could drop into that state when you don't want to. So that's my 2 comments.
Yeah, and Kevin's just saying that the metrics of the slider bar are in quote unquote the document. But what I'm hearing is that we all kind of agree that there's a mixture of hierarchical and decentralized. It's just where it takes place, and that depends upon the mission. So anyway, I agree with everything that's been said. It's I guess the word semantics. It's the same thing being said in different ways.
Yeah. In general, do people agree that treating the agents as close to people as possible makes sense? Like, the idea that the training that the agent gets mirrors the training that the access to information that the agent gets mirrors the information that a human performing a similar function with similar roles and responsibilities would have. Because that's another area where there's 2 camps, and there's people that say, no, like, if you really want agents to work very effectively, they should be working at the token level and sharing tokens amongst themselves, and cutting out all those embedding models where you take the kind of the semantic representation and just communicate that, and don't go through a language, a human readable language in between.
Well, I mean, I'm going to make one more comment. You can't fight with millions of years of evolution. Okay, I mean, humans have been working on organizational skills for thousands of years, and so why try and reinvent the wheel? So I personally, I would go with what Kevin's saying. Try and make these systems operate as close to humans as possible. I mean, that's my opinion.
Kevin,
Isn't interesting?
I agree for
maybe a slightly different reason. In the long run, I get the argument of you let the AI systems communicate with their own protocol, which is tokens, and you're going to get the maximum benefit out of that. In the near term, there's just the practical concern of the force structure adopting these things for real, and trusting them. And if you don't have interfaces that are human interpretable and behaviors that are human interpretable, you're not gonna progress towards actually fielding them. So for this type of a project, of being at the level we are now, I think it makes a lot of sense to say, you know, let's build something that does something that a human understands, because it's very much like a human would do, or a set of humans would do. And then the research eventually might progress to, well, it turns out the bottlenecks are actually the human way of doing things. A parallel to that's probably like your higher order, your F-35s of the world are, at this point, the dynamics that they can do are beyond the capabilities of what a human pilot can handle in terms of G-forces. So at some point, the pilot is the limiting factor. And I get the feeling that eventually, once AI is controlling those types of platforms, they're going to be pushing limits that humans couldn't, right? So it's kind of the same flavor of thought.
Yeah. In general, I'd like to hear opinions of whether this could be, I'm thinking of proposing it as a government reference architecture as part of the MOSA standard. Like, there is a government reference autonomy architecture, which kind of covers the agent part, but doesn't really talk about the organization or missions. I'd like to hear if people have any thoughts on that, and whether they would, or even as an open standard, would they be interested in contributing to it?
I'm just going to chime in again and say my concern with standards is it slows down research. You just, every time you get to a point where you're dealing with the standard, it takes forever to do anything in accordance with that standard. We're kind of in part of the conversations around WOSA, this weapons open system architecture, and being able to do autonomy for those types of platforms. And, one of the conversation at this point is like, well, what data should be exchanged between the agent for a weapon platform? And there's all these opinions being thrown out. And in the end, my general opinion is, well, I don't think enough research has been done to even know what the right data that should be exchanged is. And as soon as you constrain that pipe to say, oh, well, we can only send, let's say link 16 type elements across, you're suddenly going to handicap the capabilities of the autonomy, because you're potentially not sending all the right data. So it's like we haven't quite gotten to that point yet. So for me, trying to do research on a phase 2 SIBR and adhere to an open system architecture, or even try to build one, feels like it's going to be a tax on our ability to do the core research that needs to be done.
Yeah. Why is it slow for is the problem with the weapons GRA is just because it wants to be, it wants to actually specify what information gets transmitted between the weapon system and the agent?
Well, when I say slow, it's like from how do you manage a project? We're supposed to be doing something with AGRA, the autonomy government reference architecture, and literally it's being developed by our customer, or a subcontractor on a program. They're developing AGRA, but they're not allowed to distribute to us as their subcontractor. We have to go straight to the Navy to get the deliverable that they're delivering. And it takes like 3 weeks for us to get the latest version. So we're constantly chasing our tails with an old version of the software as they're evolving the next iteration, and they can't share it with us. So it's just like stuff like that.
Yeah, but that's not that seems like I don't know, somebody could fix that problem, right? That's not a...
I agree, but it's just an example of it's just an example of where research can slow down when you're trying to adhere to government reference architectures. So that's my thoughts.
Hey,
Kevin,
just
sure.
this is interesting. Just to clarify one, like, what would just expand on, like, just back to your point, like, are we interested in that architecture? Expand on what your goal would be for this? Like, to what end would you be thinking about? Like, maybe just help me understand that for some kind of architecture about this like semantic construct.
Okay, so what like what would it actually mean, nuts and bolts? I would say there would be
like not necessarily that, but just like help me understand, what are you trying to accomplish with this architecture that maybe would be a unique role and value prop for the government doing it?
To speed the development of organizations of agents, or integrate agents into existing organizations, but to speed that development and demonstrate a capability soon, right? It's like I don't think it's I think the benefit of this approach is that it lines up with like where Anthropic and OpenAI and Google are heading, and there's between MCP and the other work that's going on, and I don't want to, MCP might not be the answer, but to me it looks like a really good short-term approach. But now if you use a model like that, your company develops some agent, right, that flies a drone. But if another company develops an agent that's doing something else, maybe it's back office stuff doing ISR, if it's using a common framework like agent to agent, now you don't have to develop the additional software that would help those two agents communicate. And I think the real opportunity is that, because if we define everything so that it's communicated in natural language, like people can understand it, but also agents with different backgrounds and different companies should be able to read that document and interpret it in a similar way, if not identically, right? And now you could say, I can build I'm going to use an Air Force analogy, right? And it's like, I hate to talk weapon systems in calls like this, but if you think of a strike package going in, right? There's a mission, and includes a strike package, and there's some F-35s are going to deliver something. But over here, there's a Navy Growler that's going to provide some jamming. There's a rivet joint that's doing ISR stuff. There's tankers that are providing fuel for all of these. And they're if you think of those platforms, they come from different companies. They're operated by different organizations or different parts of the same organization, but they coordinate together because they use a standard language, right? And I'm saying, wouldn't it be really useful if I could do that with agents, so that if one company develops a robot and it can be integrated into this organization, and that people can learn how to use that, because it's going to have the same type of interface as other robots or agents, and that those agents can actually communicate with each other. And because they can share, they can identify themselves and share where they are in the organization and what their roles and responsibilities are, that you can have trusted communication between them and collaborative behavior.
Yeah. The bottom line, I agree with Kevin. Basically, no matter what application or market, you're increasing functionality and lowering the cost, and that is value. Okay, so that's the key here: increasing functionality, regardless of what mission or market, and you're lowering the cost at the same time, and that ratio is going up, and that's a value proposition. That's where I would start.
And I think, and Jim's good with getting to like what the bottom line is. I think if you wanted to deploy drones, and you say, well, the Anduril drones are over here and they can do these things, and here's the people that control them, and over here we have the drones from Lockheed Martin, and now we're going to try to integrate people into our manned platforms that know how to communicate with these drones, and it's all very specialized. I think that's what Jim would say, is that's not going to be valuable. What you really want to have is a new system comes along with new capabilities, and you can integrate it into the organization with the people and with the agents. And that's where these open standards, open systems come in, like MCP and agent to agent.
Yeah, totally agree.
Okay.
Yeah, it's increasing the functionality at lower cost. I mean, that's everything Kevin says revolves around, sorry to repeat, everything he says, if you boil it down and distill it down, it's increasing functionality at lower cost. So therein is my last comment. Oh, shut up now.
And Jesse, does that make sense, or do you? I don't want, Jim. Thank you. I love that you say you agree with me, but what I'm really looking for is the people that don't. Like, where are the things? Like, what are the, like, concerns about the performance on blockchain? It's like, yeah, that's something that should be addressed, and that for things that need high performance, like here's how we could do it with maintaining the same overall architecture. But I
would say this, like, just current reflection on that. I don't disagree. There's some unique risks, I think. One of them being is that this world is developing faster, I believe, than anything we've ever seen in the history of humanity. And there's a very real risk that there will be a standard out there that ends up becoming an albatross around our neck. I think that's a very real risk. We've actually seen that happen with other government standards. So I'm probably not the only one on this call that has a little bit of scar tissue with that.
Oh,
I think that's definitely one risk that I'm very concerned about. I do, as a patchwearer myself, I love any integration stories. So, like, I get the integration piece actually makes a lot of sense to me. I'll give you something pragmatic. Like, I could imagine, if you had an MTEL, and this MTO's full of humans and agents in this task org, and you're like, hey, this human does this agent does this. That's actually useful for clarity. Like, I can see that. And I can see that with the mindset of fight tonight, right? Something we can fight tonight with. So we do that. And I don't know if there's an easy answer for this. It's just something I'm thinking about, is that, okay, we, on the industry side, we develop something that meets the standard for this MTO that been put up front for us, and then all of a sudden the government realizes that we actually don't need this human there anymore. We don't even need this human there anymore, and we end up changing the org because the agent does it better. And I think a lot of like C2 functions the KAOC is going to start, and it already is starting to see this. So then we might end up chasing kind of last year's problem set with it. I would just say that's a risk. I'm not saying that changes the approach, but thinking how we mitigate that risk, I think would be probably edifying.
Yeah. And the kind of a related thing is, one of the other things we're working on is the Air Force ISR enterprise architecture going forward. And the model there is like, it's probably not, bringing AI in is probably not going to reduce the people that you have. What it's going to do is improve their performance, because we're looking at like more and more data coming in, and the question is, how do you change the enterprise architecture in the next 5 years so that you can handle maybe twice as much data, or order of magnitude more data, and do it more effectively, especially more effectively than anybody else? And I think the answer is, you need to take advantage of commercial technologies. Like, this is not, when I say it's standard, the standards that I'm pointing to are commercial open source, right? It's not, there's no trademarks or proprietary on MCP or agent to agent. It's open source, and it's, and I think if they're designed correctly, when their successor comes along, it'll be easy to transition from the current ones to the next generation.
Yeah, Kevin, I would say that especially when you're talking about ISR, standardization is really just not going to be your friend in this space. I mean, even when you look even at like large language models, without sort of worrying about multi-domain, in the last 9 months, we've gone from just sort of raw transformer architecture to GRPO, which is reinforcement policy optimization, which is like kind of this thing where we would train the transformer model, and then afterwards we would do kind of this agentic training on top, where you do this chain of thought thing. And then even in just the last month, we've realized there's been some papers out that we're not doing what we thought we were doing. So they found the training just purely with random policy. So instead of like putting up chain of thought to like have sort of think this, think that, get to the human conclusion, but the random policies, so just like literally randomly trained with a policy, are performing just as well. So a lot of what we think we're doing in this agentic space it's just not what we're doing. And then when you talk about ISR specifically, and the one thing that really stands out is that specialization is a thing. You know, how many different ISR platforms does the Air Force fly with different sensors? And, you know, if you're talking about, you know, here at Mach, we're big fans of multimodal embedding spaces. So, you know, if I've got a signal sensor, you know, integrating that at the base level into the foundational model is going to provide me capability. And I'm incentivized to not put every capability on every platform. So there's not, I mean, you start talking about, you know, we're going to communicate in natural language. We're talking about real limitations on the capability of the asset.
But the communication that comes off of it, if you think of it as like if, I don't know, I've looked at your website before. I'm not sure exactly like what you're you know, what you're talking about here, but if you had some special sensor and it's developing some, you know, new type of intelligence products, it has to offload them some way, and it almost doesn't matter if it was a manned platform or an unmanned, right? The way it contributes to the organization shouldn't depend on whether a person reviewed it or it was done completely autonomously, right?
I mean, I'm a real big fan of embedding spaces. So, I mean, you know, in the language world, that's a
okay.
vector of floats of length 768 that represents a sort of latent meaning. And in the signal world, you know, you can have a joint embedding. You know, Meta has this thing called the joint embedding architecture that is getting a lot of popularity, where you might mix language and something else. So language and vision are common. You know, you can do something like language and signals. If you're saying, hey, we're gonna go to language, you're kind of giving up the joint embedding spaces.
Yeah, but you those joint embedding spaces don't work cross foundation models. Like I think what you're talking about is like, hey, if they all have the same foundation model, then you can work in that embedding space, which is, I think, the future, right? Like that's out there. But in the short term, that would require that I always use the same foundation model, I think, right? Because the embeddings that the model has, they're specific to that foundation model. So now I've got to make sure that like everybody's on the same page, basically, and now we're doing a mind meld. But I think you know, having a lot of diversity in the organization is a good thing, and that way there you could have like an Anthropic foundation model should be an agent built on that should be able to communicate with an agent that's built on the Gemini model or OpenAI, because they're operating in natural language space, and people that are on that network can also understand what they're doing. But I understand the benefits, like, of the, you know, doing things in the embedding space for special cases. But I think in general it'd be like if people had you know, spoke their own language in you know, in your organization, and you had no idea what they were talking about, and they talked really fast. You know, you'd be like, what's going on here, and how do I understand their decisions? They would. I think that goes back to the safety, security, and reliability. You give up some performance potentially to buy reliability and, you know, safety. It's a good discussion. Like, this is I really appreciate the pushback, you know, on some of the stuff, on all of this stuff. I don't know if that was enough for everybody. I really appreciate your time this afternoon, and if anybody has any further comments they want to share, you know, just send them out to the group or to me directly. But, anybody have any last words? Yeah. Hey, have a great weekend. Really appreciate your time today. Thank you.
Thanks, everybody.
Have a good one.
Thanks all. Thanks, Kevin, for doing this. Appreciate it. See you guys.
Thanks. Bye.